Yeah. I'm now in the fun position of being the only thing that stands between you and lunch for about an hour. So that's going to be great. Um, so let's just have a quick show of hands. Who would say they write code at work? Yeah, yeah, a lot of developers around here. And would you say you mostly write C++? Yeah, that's not me, unfortunately. Would you say you would some of you be working with embedded mostly? Yeah, yeah, we have some embedded developers. And who would say they know how to code some Python? Yeah, that's a lot of people. And I'll make it my goal to make this relevant for all of you. But quick disclaimer, I'm gonna have some Python code examples, but you can do this with C++. So hopefully, yeah, nobody's leaving yet. So that's good. It's hard to have a title like this and be humble. Yeah, I'm just keep adding question marks and yeah, please send some help. I definitely do write bugs, and I try my best uh, to not have catastrophes happen. And in that, I found a tool that's both fun to use and rather quick to use, and it saves my ass. So, um, first things first, about me. Why am I here? Why should you be listening to me? When I was at university, I was quite interested in a programming language called Haskell. You might have heard of it. It's quite academic, very beautiful, and it had a fantastic library called QuickCheck, written by, among others, John Hughes. And that was sort of revolutionary to me. My bachelor's degree was in mathematics, so this just fit my brain so well. And then there's sort of the kind of the ugly part of like, well, the real world and stuff. But apparently, as it turns out, yeah, that fits quite well there too. So when I started working for Equinor, where I still work, I kind of I pushed for this. We should try doing some of this property-based testing stuff. And it started out with me kind of sneakily trying this out with my own stuff, and then after a while it kind of grew. Last year I had a statistician come to me and say, one of my coworkers say that I used to hate testing, but this is amazing, and it's fun, and it found some bugs, and we're gonna get to what that is. But last January, we had a bit of a course. We invited Thomas Art, one of the, I would say, pioneers of property-based testing. He talked about how they use their framework written in Erlang to test code for Volvo, and they found bugs in Dropbox and so on. So this kind of goes on beyond what kind of programming language you use and more into like you need a good tool. And there is a very useful and easy to understand tool for this called Hypothesis, and I rank it very highly because I love working with it. So that's what this is about. This tool. At the end, I have a link where you can find how to do this in pretty much any language. It's a long list of frameworks that do this. So there's two parts to the talk. First, we're going to look at the sort of time bombs that I'm talking about, the kind of the core sort of problem we're trying to look for, and then we're going to look at the technique. And luckily enough, yeah. So if you want to see how this works in practice, all our Equinor has a lot of open source code. All the code I work on mostly is open source, so you can go and look at our production code, and if you doubt what I'm saying now, where I'm showing these simple examples, you can go and point out, look, no, this isn't what you're doing, or find out for yourself that yeah, this is what we do. So luckily this summer there was a big catastrophe. Well, luckily I say, but luckily for me because I can show it for you as an example. CrowdStrike did something that that crashed 8.5 million devices very quickly. So there are many ways to dissect this. One thing is the memory unsafe operation that they did in kernel mode, essentially an array out of bounds read. And then there was the configuration they sent, which was validated but not good enough, and then shipped to this thing, which then blew up and blue screened the machine. And CrowdStrike, they came out with a root cause analysis. The file they sent, the configuration, this was called the template file. And then there was this latent out-of-bounds read related to this template file. And the reason why this had never shown up before was that the last element in the template file had this wildcard in it. That meant that you never needed to look up this array index. But it was tested. But of course, the test data they used also had this wildcard in the last index. So they managed to test the correct case, but they never tested beyond that, or tested the case that worked, but no cases that didn't work. Going on, this is also a pretty fun, well, fun for me, not fun for it. About 2,000 flights cancelled. The people who were going to take that flight. There was a UK air traffic failure. This was, I believe, September last year. That was blamed on an extremely rare set of circumstances involving two identically named but separate waypoint markers outside the UK airspace. And that's pretty much what they said was the cause of this, so we don't really know more, but it seems sort of something that was deemed unlikely, but then actually happened. And yeah, they had installed the software for 5 years and handled 15 million flight plans, but then after 5 years, boom, it blew up with this as the outcome. Of course, those 5 years included 2020 and 2021, also known as the Corona years, where there weren't that much flights. This is quite of a scandal that's been happening in UK. You might have heard of it, the post office scandal. Hundreds of post office masters that have been falsely accused of embezzling or fraud. And perhaps what was new last year was that they interviewed one of the developers that had been on the project, and they said, well, yeah, there were a lot of bugs in this software, but there was also an immense pressure to ship it because it was over budget. It was written about as an enormous IT scandal. And then Wikipedia lists that there's been at least 4 postmasters that committed suicide as a cause of this. And of course, then this developer said, you got to throw it away and rewrite it. That's a very weak position to argue from, of course. So, but it emphasizes that you don't have infinite time to actually ship something that's bug-free. There's eventually there's going to be pressure. All right. So stepping back a little bit, what was it that we wanted our tests to do, kind of in the general? Well, one thing is to be able to go faster. This is often touted as a main reason to actually write tests. The why do cars have brake argument? Well, you need brakes on cars because the cars need to go at a high speed. And we'll get into that a little bit. Of course, then there's the other part where the programmer wants to ensure that the program does what I intended it to do. This is usually just called correctness or some fit for purpose sometimes. And then the flip side of the coin, where is that the program doesn't do anything bad. And now we're into things that are usually called security something, memory or safety something, memory safety. And the way I think about it, so here, this, like, how does this help us go fast? How does this help us avoid problems? So I'm in this box and coding, so I'm debugging, and then so later on I will have to do some debugging. Before I've started, there are certain things in place that help me avoid faults in the first place. Okay, that might be design. So the kind of the architecture is designed in such a way that I avoid creating bugs in the first place. There's my experience, there's the team's experience, the organization's experience with making software. That definitely does help. There's the scope of what I'm trying to do. Of course, if I'm trying to do something simple, then maybe I might get it right. And coding standards certainly play into effect here. And then by keystroke, you get this sort of feedback: the syntax highlighting, the compiler errors, linting, of course. Then sort of save by save, you get the fast tester running. There's maybe some static analysis running. As we get even further down, we now get slow tests. You might do some form of verification if we're talking mission critical software. And then finally, there's the someone else tells you that you did something wrong, and hopefully it's a coworker and not a police officer. The good thing about property-based testing is that it does, in our experience, kind of span both the fast test and the slow test phase. So you can do this quite early without having to involve some sort of specialist who knows what they're doing. It isn't that difficult to do. And also it runs fast, if you have fast code that runs fast, that is. All right. And if you just humor me for, yeah. So what kind of, if we look into sort of the software that's usually don't have bugs, well, then I think in compilers they have kind of this. There's almost like a joke. It's never a bug in the compiler, except compilers do have bugs sometimes. And it kind of interesting thing with C compilers is that there is actually quite a lot of fuzzers for C compilers. Here's just one example. I think this came out of the University of Utah, called CSmith, which says it outputs C programs free of undefined behaviors that are randomly generated, not a small feat. And then they feed it to the compiler and they find bugs. And these are not the only ones that do that. So of note here is that it's not just random text, of course, because if you feed random text to a C compiler, you get this one, unless you have a very good fuzzer, then you will mostly be hitting all of the syntax errors that you could hit. But these are actually valid programs, so it's now testing something beyond that. And that's the sort of thing that we're going to look into. In order to do that, I created 2 characters. I've done this internally, so I need to, have something to point the eyes on. So I came up with some names here for the part that is the test data generation. So let's call it the Chaos Monkey, obviously named after the Netflix tool. just responsible for coming up with chaos. And then the other part was the test oracle, the one that determines correct behavior. And and one part that is obviously not, not a candidate for a test oracle is your program, and that is a thing that's quite often happens when you do this sort of techniques, is that you reproduce the code in the tests, and then you're testing nothing, of course. So what is it? So what is it that it's supposed to do instead? Well, that's a little bit up to you, but we'll look into techniques for like thinking about it in such a way that you can come up with a test oracle that isn't just reproducing the code in the test. And these guys are gonna have some interplay. The absolute simplest case we can come up with is that the chaos monkey is going to come up with the test data, and then the oracle is just gonna decide whether the program executed correctly for that input in somewhere. That is the simplest case. The monkey just comes up with the test data, the oracle just looks at it one time, fine. And now comes some. So we have the Python code examples. So here is a kind of normal. Well, it's quite usually shown test. We're testing sum here. We have this property-based testing framework called Hypothesis, which gives us the test data generation. Hypothesis has this concept of strategies. This is the test data generators, the different kind of data you can generate. And we simply say we have this given decorator. So given that A is an integer and B is an integer. So these are drawn from the integers strategies. And then we have our test. It takes those that A and that B and checks whether sum is correct. In this case, it's just commutativity. A plus B is equal to B plus A, and this obviously works. The default behavior is to run this with 100 generated examples. You can tweak it if you like. They have tools to run it overnight if you're really paranoid. And that is the simplest case. Of course, you can tweak what you generate. So here is an example where I've generated some classes. There's a enum, which is a role. You can only be an admin. And you have a person. A person has a role, which is that enum, a last name, and a first name. Both of those are strings. And then I can use the builds strategy, give it the constructor person, and then it goes and looks at the types and just determines that you probably meant to use the most general generator for those types. So string is going to be any text, role is always going to be admin, and so on. And we can test our login. Then you can take this generator as a combinator library. So here we take the generator for integers, and we say filter, take away all the integers where modulo 2 is equal to 0. So that is all the odd numbers. Yeah, take away filter. The ambiguity, you have the ambiguity of filter. Does it take away the true ones? Does it keep the true ones? So here's so in practice, there are sort of a limited number of properties that you are going to encounter, but this one I have written many times. This is these two functions are inverse. That's because if you have serialize and deserialize, you want it to be inverse, that when you serialize something and deserialize something, you get the same thing back. So here I've taken a hypothetical example where you have an application where you have this state, you can save and load the state, and then we build the state, and the test simply then saves the state, so serializes it, and then we load that serialized state, and we assume that you get the state back. You would also think that that if you first load something and then save something, you get the same thing back. But of course, if now we're getting into the kind of the security domain, because if you're giving arbitrary input, then it might not be valid state. So let's have a little bit look at that. So we're in the same situation: save, load, state. But this time we're giving bytes, so we assume that this is serialized to binary. So given this sequence of randomly generated bytes, now I'm going to try to load it, and now I have some state. I'm not quite sure whether immediately saving that state gave me the same sequence of bytes back. There might be something in there that's timestamp, or if you're serializing text, that might be why it might be white space might be ignored, and so on. So I'm just going to have the same assert statement as before, that if I then save that state and try to load it again, now I have the same state back again. But because this is arbitrary bytes, then what's going to happen, much like the C compiler example from before, this pass is going to happen pretty much always. And the reason for that is that there's not many sequences of bytes that are valid. So we'll have to do something about that. So what we then do is that we need to do something with the generator. So we can so what this does, we use another strategy combinator, which is called one of, and what it does is it arbitrarily chooses one of the generators that it has been passed. So it might say, okay, let's try completely random bytes this time, or I have some other generator that I've created that tries to steer the situation into things that are sort of valid, or maybe even always valid. And that way we are more likely to hit the assert statement rather than the accept clause. Yep.
How do you distinguish like a validation error that is expected rather than a bug?
Oh yeah. So the thing is, of course, this is sort of a general thing, is that we have to be sort of abstract and vague about what we expect, since it's with arbitrary inputs. So we're not testing specifics, right? So we're taking a step back and using properties that are universally true, but don't clamp down on exactly what the behavior is. So if you remember the commutative example from before, if you know some abstract algebra, you know that there's actually a lot of ways of satisfying commutativity without being the integers. There's the integers modulo 2, or the booleans, for instance. So you get that sort of abstract ideas by each thing will test something that many things can satisfy, and maybe many things that aren't correct can satisfy. So this state, I mean, we could think that, well, the state is always none, for instance, that's or not some null object every time, and it will still satisfy this. So we will have to write more tests to narrow down the behavior that we want, and for that it might be a good idea to use regular unit tests rather than this. But you could probably come up with, depending on what kind of state you have and you want to describe. So here we're describing serialization, deserialization, but you might describe other concept aspects with property-based testing as well. Did that answer somewhat? Okay. Okay, cool. So yeah, another example. So here we're testing an average function that I've written. All it does is it sums the numbers and divides by the length of the list of numbers. So very naive average. More on that later. And I've long block, a long line of text of the generator. But what it is that it generates lists. And what are the elements? The elements are floats, and bear in mind no nonce and no infty, just so that we get those out of the way. We don't, average is not going to really work for that. And we have at least one float. So the minimum size of this list is 1. So now given this list of numbers, all I'm asserting is that the maximum number is greater than or equal to the average. So under normal conditions, you would say, yeah, that sounds reasonable. But of course, if you think about it, say, well, there's loss of precision, and average is one of those with catastrophic loss of precision, since I'm summing together numbers and dividing by the length. So it turns out this doesn't work, and under normal circumstances, a developer will not, think of the kind of inputs that will invalidate this. But it does. So let's look closer at that. What sort of example? What does hypothesis do when there's a failure like this? So what I've done is, okay, take that Boolean value. Let's call it success, and then I'll print the numbers and whether it was successful, and then the assertion. So now we should see the printout of, okay, which numbers did this produce? And this was from a run with hypothesis sometime last year. So things might have most definitely have changed, and there's random pseudo-random numbers involved here. So, but the first thing it tries is like, okay, the list with just a 0 in it, and that is the kind of your minimal empty example. Let's just try one of those, and says, yeah, it works with 0, and then it tries again, 0. Oh, but yeah, so it's trying to suss out whether this thing is actually, your test is actually flaky, like you get different result every time I run it, and it's like, no, it still works. And then it tried some longer list. It tried some very small numbers. It tried some, still very small numbers, and then just some sort of regular minus 1.1. And there's more. And then it came to something where it failed, involving 23 elements. So now it's failed, but it keeps going. And then what it keeps going with is a feature called shrinking, where we're trying to come up with the smallest counterexample. And the reason for doing that is that for debugging purposes, so that later on you have something small to look at. And that smallness can also sometimes kind of give you the, aha, it's probably one of these problems. There's a fun story by John Hughes, one of the developers of QuickCheck. There was a bug with the database of Klarna, if you know the company, and they had all sorts of hypotheses about what is causing this corruption, and they thought like, well, maybe it's something when the amount of rows exceeds 1 million, maybe something, they didn't quite know what was going on, and it was hard to observe that this had happened. But then they did one of these techniques, and they could reproduce it with 3 steps. First they open, and then a close, and then 3 things happens in parallel. And then because it had this small counterexample, they knew exactly what was going wrong, right? Because you have these 3 steps to try. Yeah, so that's what we're trying to do now. So then it takes two of those numbers, but that worked. Okay, so let's go back. Let's try half of the numbers now. So it's 11 of those elements. You notice that one of the last element is still in there, and that fails. And then it just tries iteratively to come up with the smallest counterexample, and that what it ends up with is these two very large numbers where you get catastrophic loss of precision. So that's so that's a very useful feature when you are going to debug what happened. And now we're getting into maybe the advanced, somewhat more advanced feature, which has been very powerful, and it's sometimes called model-based, sometimes called stateful. And we're going to use the Flask blog post example to illustrate how you might use this. If you're writing a normal unit test, you might test login like this. You take some sort of web driver, you have some sort of test user. We're going to hit the auth login with our credentials, and then we're going to assert that we get redirected to the homepage, and then check. Now we need, okay, well, we need to check that the right user is logged in, and so on. So quite a normal setup. Of course, what these things, this is a quite simple test. You don't really expect anything to fail with one step. This is sort of what this is sort of a situation where things might happen, where you log in as one user, Alex, and Alex creates a blog post, and then you log in as Annie, and you try to view the blog post, and all of a sudden it blows up. So that's sort of the kind of situation that you might find a bug, but just doing the login once, I really expect the developer to do that on his laptop. But these complicated, many different things happen. Now we're getting into a situation where it's a little bit more difficult to do this on your own. So we're going back to our characters again, the Chaos Monkey and the Oracle, and they're going to cooperate a little bit. What's sort of going to happen is that the Chaos Monkey is going to go and actually do all of these things. So imagine him going on a train ride and actually going on the train. And then we're going to have the Oracle just look at the subway map. So that subway map is now just your model. It's unsimplified, not accurate. There's no bridges or anything on this map. It's not the scale. He's just looking at something a lot more simple to kind of understand what is supposed to happen. So here's the sort of scenario that we are going to do. So the Chaos Monkey is going to say, okay, now I signed up as this username, perfect, and say, okay, yeah, the username is that thing, and you are not logged in yet. You need to log in first. Okay, and then the Chaos Monkey logs in. Yeah, now you're logged in, and it says log out. Okay, now logged in. Now you're not logged in anymore. And then the Chaos Monkey creates a blog post and says, "Oh no, not logged in. You shouldn't be allowed to do that." So that's the sort of situation. And the framework does provide what they call a rule-based state machine to do this, and it uses these rules. The rules are the actions and the subsequent check by the Oracle. So so we set up this state machine, and we need so here's the constructor. First thing it does is it starts the application, and then it sets up the model. The model is just a dictionary of registered users and their password, and whether or not the name of who is logged in currently. And then we need some teardown to clean up the database and so on. Yeah. So here's the register rule. It uses this rule decorator, and it uses the precondition decorator. So the precondition tells this rule-based state machine whether or not it can apply this rule now. And the rule takes generators, so it takes a username, a string that's not empty, and a password, also a string that's not empty. And now we get to this. Now we get to the actual rule. The rule takes the username and password, and then we have now we have an assume statement saying that the username is not already registered, so we don't want it to register twice. This then assumption, if it fails, we stop applying the rule. So this is a way to easily generate usernames that are not already registered by filtering them out. We had hit the register endpoint with the username and the password, and then afterward we check that we get redirected to the login page, and we set the and then finally we update the model saying that the username is now registered with this password. Going on, we want to be able to log in. So here I take a fun little object called data, which can be later on used to draw values from whenever I need to it. So you'll see that. So I now need call self registered users to draw out draw one of the registered users from the dictionary. So the registered user now assumes that there are registered users. It's not just an empty collection. And then it uses this draw function to take an integer and takes the list of registered users, selects the ith user. And now we can do the action. So we take we hit the login endpoint with the username and password, and now we check that we get redirected to the homepage. And we can set and then finally update the model saying that, yeah, this user is now logged in. So then the next thing is log out. You've seen this now. We have a precondition. The precondition is that there is a user that is logged in. Then the user just then we just hit the logout endpoint and check that we get redirected to the home page and that there's no logged in users now. Yeah.
So that I'm clear, so the precondition should be is not now.
Oh yes, absolutely. Sorry, a bit of a typo. Yeah, it's not now. You are correct. Sorry. Weird. I'll have to go look how the copy paste went wrong. And then finally create a blog post. I've just filled in an empty title and empty body. You can use generators to generate the title, generate the body, of course. And now we get to the two things can happen when you try to create something. Either if you're not logged in, then you should be redirected to the login, and otherwise, okay, it was created. And that's the entire way to do this, and no bugs found so far. But of course, this is just you can this kind of illustrate that you can start with a quite simple model. There's just who's logged in, who's registered, and that gets you going. And now you can expand from there, going, well, if I have created the blog post and I assume I should be able to get it on the homepage, and so on. Yep.
Maybe I'm not following the code single value.
Yeah.
Does it mean only a single user can be looked at?
Yeah, so that's also a simplification of the model. I'm just using one user at a time. You could, of course, extend this to having multiple users logged in. But yeah, this is using one client logging in and out, but you can have multiple clients if you like. This was just the simplest way to get started. All right. And then where to go now? There's a quite good. I recently updated this list, not my list, but I gave him a pull request of a list of property-based frameworks that you can use for different languages. So let me just. Oh, okay. Give me a moment. The Wi-Fi. Just get the Wi-Fi here. Yep. No. There we go. And you can look through. There's some background here about using it in automotive software, and there are several different frameworks you can choose from. We had a small chat during the workshops this week about the C++ one, rampant check. So it is possible to do this in C++. The feature that I demonstrated is this one, the state machine, and as you can see, there's not everything supports that, but maybe you don't need to. All right, and with that, thank you so much. And we have plenty of time for questions, so.